When a complex supply chain collapses under pressure, the failure rarely starts on the loading dock. It begins with a breakdown in systemic quality control. Mention ISO 9001 to most professionals, and they picture an endless bureaucratic exercise, a series of static checklists used to generate compliance paperwork and satisfy external auditors. But that perception misinterprets the design. ISO 9001 is a formal operational architecture. It is built to ensure continuous consistency and output quality as a business scales. Treating this standard as a static rulebook leaves an organization vulnerable to the exact catastrophic supply chain failures that destroy scaling businesses. Instead, it is an active, powerful operational engine. The foundation of this architecture is the high-level structure, or HLS, the underlying skeleton of the ISO 9001 2015 standard. The HLS is composed of 10 specific clauses. Together, they form a framework that forces daily process outputs to align with broader strategic objectives. The first 3 clauses establish terminology and scope. The real power lies in clauses 4 through 10, active operational components functioning as a continuous loop. The mechanism powering these active clauses is the Plan, Do, Check, Act cycle, or PDCA. To guarantee quality, an organization must abandon the compliance binder and learn to operate this continuous PDCA engine. Before the operational loop can even begin, the system requires a foundation. That foundation is built on clauses 4 and 5. An organization first defines its exact environmental context, identifying internal and external realities, logistical constraints, and stakeholder needs. Inside that context, the standard demands active executive involvement. Clause 5 requires leadership to directly establish the quality policy, rather than delegating it to a mid-level manager. A quality system without environmental context and executive leadership is a machine built on sand. It cannot sustain the operational cycle that follows. With the foundation set, the Plan, Do, Check, Act cycle snaps into place. The plan phase is mapped directly to Clause 6. This is strictly where performance objectives are set and operational risks are identified. The Do phase encompasses clauses 7 and 8, governing resource allocation, infrastructure management, and physical production. The Check phase executes Clause 9, creating the absolute requirement for internal audits and objective performance evaluation. Finally, the Act phase executes Clause 10. Nonconformities are systematically corrected, driving continuous improvement back into the next planning cycle and starting the engine over. Standardizing daily operations across this specific 10-clause map guarantees that outputs consistently align with strategic objectives. Management theory becomes verifiable action. To understand the 2015 standard's primary update, we really have to look closely at the planning phase, specifically Clause 6.1. Legacy quality standards relied heavily on the idea of preventative action, which often meant patching processes only after errors occurred. The 2015 standard mandates risk-based thinking. This is a proactive requirement to systematically assess vulnerabilities during the planning phase, well before physical operations begin. This chart shows how risks are mapped on a 2-dimensional grid, quantified using 2 specific metrics: probability, or likelihood, and impact, the consequence severity. Multiplying probability by impact generates a risk priority number, or RPN. High RPNs dictate exactly where leadership must allocate resources. Risk-based thinking moves quality management from a post-production inspection department into an executive-level requirement for design. Consider how this applies in a high-stakes environment, like a pathology lab operating under ISO 9001. During Clause 6.1 planning, the lab identifies a specific catastrophic impact event, the potential mislabeling of a patient's physical diagnostic specimen. A traditional, reactive approach would wait for a mislabeling near miss to occur, and then issue a corrective training memo to the staff. The ISO 9001 intervention alters the core operational design. The lab proactively implements automated barcode scanners, equipped with hard system verification stops. This hardware intervention mathematically drops the risk priority number on the matrix. It simultaneously reduces the likelihood of human error while introducing a strict detective control. Embedding risk prevention into the process design secures patient safety and operational integrity at the source. This architecture fulfills the auditor's checklist while providing a permanent mechanical safeguard against error. Deploying this architecture is a major, time-intensive organizational effort. Building a mature, audit-ready quality management system typically takes 6 to 12 months, moving through 3 distinct blocks. The first phase, preparation, requires a rigorous gap analysis comparing existing processes against the ISO standard. This is followed by implementation and a formal 2-stage external audit. Organizations that attempt to rush this timeline or skip the initial gap analysis inevitably suffer critical, expensive failures during the external Stage 2 audit. The ultimate goal of the ISO 9001 journey is not the certification itself. The paper certificate is merely a byproduct. The true value lies in the high-level structure and risk-based thinking, functioning as permanent internal operational engines. The quality management system establishes quality as a continuous, strategic baseline for global operations, replacing localized final inspections with a systemic standard of performance.